When the first plows turned over the prairie sod, the early farmers unearthed a rich, dark soil. Indeed, across the world, some of our most fertile soils are found beneath prairies. Why is this the case? You see, prairies present a mosaic of different kinds of plant species that may just hold the secret to understanding how an ecosystem can accumulate such immense fertility. I've shown you here two soils from the same field. Would you believe that the diversity of life could turn sand into fertile soil? What I mean by that is we have experimentally manipulated the number of plant species from 0, 1, 2, 4, 8, and 16 to study the effects of what we call biological diversity. What we have discovered is that compared to any one plant grown on its own in what we call a monoculture, plots that were seeded with the diversity of prairie plants have built soil fertility. Visually, you can see this in the darkening of the color. This color change represents an increase in more than 5 tons per hectare of carbon stored in the soil, 170% more potassium accumulated, 15% more calcium, magnesium, and nitrogen, all nutrients that plants need to grow. But the amazing thing is that these changes are occurring on a human-relevant timescale. 25 years to build soil fertility on the notoriously infertile Anoka sand plain. Now, as we're forecasting forward to 2050, we have a lot of mouths to feed and a limited amount of land. If we want to prevent the clearing of our rainforests and help to mitigate climate change, seeding diverse prairie plants into our most infertile soils could be a win-win strategy for humanity. We might be able to restore our degraded lands into agricultural production and prevent further deforestation. Now, this experiment I've described at the Cedar Creek Ecosystem Science Reserve is the longest-running biodiversity experiment of its kind in the world, truly a Minnesota first. We've simply never had an experiment running long enough to demonstrate these unprecedented effects. What we are beginning to determine is that prairies may not be diverse because their soil is fertile, but that their soil may be fertile because they are diverse. That plant biological diversity can cause the accumulation of soil fertility. Thank you.